problems going on.
Oh, well, that's all right. Let's kind of go with that.
You're a computer science guy.
Yeah, the way that computers on people fix things is you Google stuff.
No, you
So that's the first step. Is you always turn it off and back on. After that, you just start Googling.
Change the
Internet
focus.
connection.
Oh,
Then you try to fix the modem. Or they
Then you try to fix the modem. Because people still use modems.
or a router.
Yeah, how's that? Come on, you don't use modem.
I think it's probably okay for mine.
yeah, it's
Anyone with
probably okay. At least
BIOS.
not read the stuff on there.
That's one thing that contacts.
Oh, yeah.
Be all right, I think.
Then it's
Okay.
plugged into the other thing.
Great. We'll just go with it. Thank you.
All right. Hello, I was expecting to see a few familiar faces in here, but no such luck. Anyways, yeah, my name is Kelson Redding. For those of you who don't know me, I just graduated last June during the middle of my second MECOP internship with Blunt International. So without further ado, I'll get into it. So
Move this way so we can actually
right,
see the.
yeah, good call. Okay, so Blunt International is a billion-dollar corporation that essentially makes chainsaw chain for the large majority of its business, chainsaw chain and chainsaw bar. So the company was started in 1947 by an OSU graduate, Joe Cox. His design for saw chain was inspired by timber beetle larvae. He was also a logger, so it's actually a pretty interesting story. He was just sitting on a log, like eating lunch one day out cutting timber, and he watched these little guys go to work, and he was like astounded by how fast they could cut wood. And he kind of took some of their natural biting ability and designed it in a chainsaw chain, which is actually the same way that it's still made today. So the patent that he created in 1947 is still modern chainsaw chain technology across every manufacturer. 1951, sales exceeded $1 million. Let's skip over a couple of those because they're irrelevant. 1985, Blunt, which was formerly a construction company, purchased Omar, which had purchased Oregon Saw Chain before that. And then in 1999, Blunt was acquired by Lehman Brothers. I'm sure a lot of you guys have heard of Lehman Brothers. They're an investment banking firm. And in 2004, Blunt was listed on the New York Stock Exchange as BLT. They own companies such as Frederick Manufacturing, Windsor, Carlton, which is another chainsaw chain manufacturer that they bought, Speedco, another chainsaw chain manufacturer that they bought, and Knox, another chainsaw chain manufacturer that they bought. So really the only markets that Blunt is in is forestry, lawn, garden, and agriculture. So they make various implements, but the vast majority of their business is chainsaw chain and chainsaw bar. So while I was working at Blunt, it was a standard 40-hour a week. Overtime was not authorized unless you got approval from your boss for some project that you're working on. 7:30 to 4, Monday through Friday. It was, I don't know if I'm supposed to tell you this or not, but I'll do it anyway. $22.50 an hour for my senior internship. So not bad. Really great for an internship, in fact. Allows you to actually get some work done. Holiday pay, 401k, health insurance. They've got a gym on site. They'll give you a subsidy for steel toe boots, urgent care clinic on site, which is actually kind of cool, and other equipment available for personal use, like if you want to borrow a weed whacker or something like that they make, they have a program for that, so that's kind of neat. So the organizational reporting structure, to me, was Josh Collins, who is the CEO, former Lehman Brothers employee. Bill Alford is the VP of manufacturing. Jason Madden, which was the plant manager. Ryan O'Shea, which was the manufacturing engineering manager. And then me. So I got to work right under the manufacturing engineering manager. It was a pretty good experience. One offered really good opportunity to kind of rub elbows and talk with all of the senior management. So you're kind of in a good position to pick those people's brains, which if you get any opportunity in your internships, I highly suggest you take advantage of those opportunities to ask poignant questions. Don't be afraid. So my major projects while working in the manufacturing engineering department at Blunt were largely centered around the chrome plating department. So the cutters on a chainsaw chain have chrome plating on the actual cutting faces of the links, the cutting links. And so in order to get chrome on just the cutting faces of these tiny little links is actually a relatively involved process, which needed quite a bit of work, so they kind of set me loose on quite a few of them. Some other projects I worked on were in heat treat, including inert gas layers in their heat treating processes, vibratory part sorting after the heat treat processes. I had to come up with a solution for replacing salt in a Ostemper heat treating process. And I worked on a packaging project to introduce one-piece flow into a box building process. So I'll get into my major projects now. The automated chrome plating line capital project development. So when I showed up to Blunt, my manager kind of gave me the lowdown on a system that was running at maximum capacity, maximum speed, and they had thrown a lot at it, and they just don't really know where to go from there. So he kind of just saw me as a set of fresh eyes and said, hey, go look at this system and tell me what you think. Tell me what's wrong and what you think we can do about it. So I kind of dove into the system and studied it for a couple of weeks and realized that one of the problems that they were having is that poor control over the vertical acceleration of the hoist that was lifting parts in and out of the chrome bath was causing the system to be set into a vibration at the top of its travel. So when the hoist would lift all the way, it would kind of slam the top, and it was a cantilever hoist. So it would set the whole system into this like really nasty vibration. And so I saw that and kind of dove in on that because that was like low-hanging fruit as far as I was concerned. It was a visible defect in the system. So through that, I kind of dove into the maintenance records. I was lucky that Blunt has some really tight maintenance records that are accessible via computer database. And I correlated those maintenance records with the increasing demand on the automated plating line speed, and was able to actually pinpoint two particular parts that were failing at a higher rate due to that vibration that was associated with increasing the speed of the hoist travel to its maximum. What I did with that information is I used it to create a budget essentially to upgrade the hoist system from a standard AC brake motor, which is what it was operating on, to a more precision controllable servo motor package. And unfortunately, we were not in the business climate to go and be spending money. As I got to Blunt, the stock price was about $18 a share, and when I left, I think it was at about $5. So the company was in cost cutting and savings mode. So what's that?
What did you do, man?
Oh yeah, I know. It's that's a larger conversation that we'll get into. But so I designed and put together this whole project and got it approved all the way through plant management and engineering management. And unfortunately, it got sidelined by the finance guys. because of inappropriate business climate. But it's scheduled to be resubmitted for the third quarter of this upcoming financial year. And the outcomes of this project are a proposed reduced vibration of the system by 25% and an increased capacity of 14%. And it was only a payback period of about 2.5 years. So it's got a high likelihood of actually being done, from what I've been told. And in identifying those particular maintenance calls that were associated with the increasing speed, I was also able to identify $16,000 a year in savings due to reduced machine downtime and maintenance costs prior or after implementation. So another project I worked on also in the Chrome department was for a Chrome system, you need to have a ventilation system that eliminates the Chrome mist from the air, because during the electroplating process, the Chrome bath becomes agitated and there's a mist that's released from the surface. And that mist is like really, really nasty stuff. So included in the Chrome plating system is this mist elimination ventilation system. The problem that they were having with this is that vibration that was being caused by running the hoist really fast was causing problems in associated systems that were attached to the main frame. Due to that vibration, it was actually causing these mist eliminators that are a part of the ventilation system to crack because of the vibration. They're made of a PVC plastic, which is constantly being degraded by the Chrome that's flowing through it. Chrome's very, very, very degradatory to nearly all materials over time, right? It's a highly, highly corrosive chemical. And PVC handles it well, but it's still being degraded over time. So that, coupled with the vibration that was being introduced by the system, was causing these mist eliminators to crack. And at about $600 or $6,000 a piece, that was a problem. So I essentially went in and went off the advice of some of the maintenance technicians, as well as the operators within the Chrome department, who had already kind of thought about this a lot. And then we worked together to put together a plan and design to take the mounting away from the main frame of the automated plating line and mount it to the ceiling, rather than incurring that vibration from the main frame. It was then isolated to the ceiling, and those ventilation system was no longer getting hit with that vibration. So the associated results on that were about $8,000 reduction in maintenance costs. For really, it only cost us $2,000 to remount these to the ceiling. So that was a super payback on that one. Another one in Chrome was an anode shield. In order to achieve even plating of the cutters across the Chrome tank, so you've got a Chrome tank, and then your part density as you reach the center of the Chrome plating tank is higher than it is on the outside. So you need to selectively shield your anodes so that you're getting an even Chrome plating across the width of the tank. And without getting into so much detail, essentially what I did was created this device here, which allows for adjustable shielding of the anodes, because the anodes are just these 1.5 inch diameter copper bars that are about that long, and you shield them by just, I mean, it is what it sounds like. It's literally a shield that just goes in front of it that's non-conductive and actually blocks some of the current from flowing from the anode at wherever you adjust it. So this allowed the Chrome plating expert, guru, magician, as they called her, to actually adjust each one of these shields for all 12 of the anodes, so that she could dial in the process to be perfectly even all the way across. Whereas before they were having some scrap issues because some of the chrome was not adhering or not building up properly on the outside cutters. So the results were a replaceable, adjustable, and user-friendly anode shield that resulted in more consistent chrome plating and reduced scrap. I'm going to skip over this one. So this was a really cool project I got the chance to work on for the chrome department. Again, was actually, when I showed up there, it was a kind of an in-process project going on for changing the chemistry of the chrome bath from a hexavalent chrome, which is a fluoride-based chrome. And that's like real bad stuff, as I said before, real bad stuff. In fact, to the point where I was kind of nervous about working in that environment. Even though they have a really good ventilation system, it's just bad stuff. And they're changing over to what's called chrome clad. It's an industry trademark, but it's it's a different chemistry that doesn't involve fluoride and fluorine. And it's much less toxic, and it actually has desirable properties for the chrome plating process, such as reduced plating times and higher plating efficiency. And as a result of this, we were going to see a 14% increase in throughput for the chrome department's automated plating line per the same energy that's being run, or the same current that's being run through the chrome bath. So with that, I don't know how many of you guys are familiar with the Energy Trust of Oregon, but if you're not, you should become familiar with it, because this is a really valuable tool for engineers in our current climate. What happens is the Energy Trust of Oregon can incentivize any project for an industrial partner that is related to energy efficiency. So I partnered with the Energy Trust of Oregon as a liaison for Blunt to get half of this project paid for by the Energy Trust of Oregon, simply because we reached out to them and we were doing an energy efficiency project and it required some output of money on our end. If they can influence the project in any way, shape, or form, whether it's just be there to study the effects or make recommendations for changes, they can incentivize up to half of the cost of your project if it saves money, right? So it's 25 cents per kilowatt hour savings up to 50% of your project cost. So in a project that was going to cost about $90,000, we were able to get $43,000 of incentive from the Energy Trust of Oregon to complete this project. Actually since got a job with the company I was working with on this project, so that worked out pretty cool. Okay, yeah, so one of the projects I got to work on outside of the chrome department was the electronic rivet heat treat is what they call it. It's actually an induction heat treating process that occurs on the rivets that hold the chain together. So as each chain link comes together, there's a rivet that holds it to the next link. And those rivets start as just a stock steel. They get formed by just like a pressing operation. And then they go through a heat treating operation for the entire rivet. And then there's a heat treating operation that it goes through for just the hub of the rivet, which is like the wide part of the rivet. And in that process, we were forming a blue oxide layer, which is actually super thin, like only angstroms thick, but it's it causes problems in downstream assembly because it chips off and flakes off. And so I got to R&D doing an inert gas layer in that heat treating process. And it's still in the development phase because it's kind of a big project, but it was a really fun deal because I got to work with the metallurgical lab at the company. Blunt actually has its whole own metallurgy lab with scanning electron microscopes and laser microscopes, and I mean, cycle testers and fatigue testers, and pretty much anything you need to understand what's happening in the microstructure of your metal during treating. So that was actually really neat. They've got a really, really great metallurgist there that was fun to work with. And so these are some of the pictures. Like here, you can kind of see the oxide layer after it's been broken up, and then this is after we included some prototype parts to actually flood the system with inert gas while it was heat treating. And you can see here that this oxide layer is actually gone completely when including an inert gas layer into the process. So that the actual total process is still in development, but we laid the groundwork in this project to show that we can get rid of that oxide layer by just including an inert gas layer into the heat treat process. Okay, so that pretty much covers like the major projects I worked on. There was a lot of just kind of random, hey, can you take care of this? Hey, can you take care of that? There was very little busy work, which was cool. Blunt, I would say, provided a very good internship. If you're into mechanical things, it sounds simple, right? Chainsaw chain, it's pretty basic. But the process from going from raw steel to finished product is actually very involved, and involves a lot of really cool, complex machinery. I was not that stoked about going to Blunt when I got selected until I went on the tour of the factory, and it's a lot of complex machines running at high speed, producing millions and millions of tiny parts. Pretty much 24 hours a day, 5 days a week. So you can imagine the implications of that. And it was really a good experience for mechanical. So the lessons I learned were develop as many portions of a project concurrently as you can. Because if you try to do it in a linear fashion, you're just not going to have time during a 6-month internship. So as many things as you can jump on at once is really going to help you out. Always assign individuals to a project tasks. I got put in charge of a few projects that involved bringing teams together, and you know, if you don't like put somebody's name next to a task with a date associated with that task, it's likely not going to get done. So that's a big one for sure. Begin to develop alternative solutions early. So one of my projects involved trying to develop a tool for a process, and I kind of knew early on in trying to develop this tool that it probably wasn't going to work. And I had another idea, but I kind of sidelined that idea just because they wanted me to go after this one way of doing it. And in the end, when we concluded that this one idea wasn't going to work, I wish I would have started to develop this other idea simultaneously, so it would have been further along. Because by the time that we concluded that the first idea wasn't going to work, it was already too late, really, for me to make any meaningful strides on the idea that I had that I thought would work. So it never hurts to have like plan B in the background, right? Monitor continuously on all of your projects for scope creep, because anytime you get involved in a system that people use every day or like or don't like, they're going to have all sorts of things that they want you to do to it. And you need to keep in mind what the original box that you started with includes, and try to focus on those things, because when the scope gets stretched and stretched and stretched, then you're never going to get anything done. Trust but verify. When you ask somebody a question, it's not that they're lying or that they don't know. It's like maybe that information has changed since they last saw it, right? So people would be telling you something in good faith and really believe it to be the truth, but the information changes so fast oftentimes that maybe they don't have the most up-to-date information. So I like to try to find the source of the information whether that be in the computer or the person making the policy or whatever. So it's always best to try to dig to the bottom of that. And one thing I worked on a lot, and my mentor really stressed in me in this internship, which I think was probably my #1 takeaway, was manufacturing especially, and probably across all disciplines, you're going to be selling your ideas and your project proposals and all of this stuff to various audiences, right? So you're going to be selling it to the people who use it. You're going to be selling it to the finance guys. You're going to be selling it to your manager. You have to sell this stuff to all these different people. So you need to consider who your audience is and what they want from this project, or what they want out of this idea, right? Like what the guy on the shop floor that's going to be using it wants a completely different thing out of it than what the finance guy wants out of it. So you got to kind of take a few minutes to have that thought before you go into those conversations, so that you can deliver the appropriate message to whoever you're speaking with. Classes that were useful: machine design 1 and 2, design project. Manufacturing tool design was really useful. Lean manufacturing and solid modeling were probably the most useful courses. Major thanks to Blunt team. Any questions? Bueller?
Where are you working now?
So the company that I worked with when I was partnering with the Energy Trust of Oregon is called Energy 350. And they are a contractor working with the Energy Trust of Oregon to implement the Energy Trust incentive program. And so I ended up getting a job with those guys.
Oh, wow. Great.
Work really hard in your MECOP internships, because they'll offer you jobs if you work really hard. So do that, because it's good. It's good to have options.
What were your first internship at?
At Daimler, in the manufacturing engineering department. Yeah, that was also really good. Some differences between Daimler, I think I was supposed to include that in this, but I didn't. So some differences between Blunt and Daimler. I think most notably is that Daimler was a union. I was working in manufacturing in both, so I dealt a lot with the actual production side of things as well as the engineering side. And Daimler was a union production shop, and Blunt was non-union production shop. So when you walk into the union shop as a manufacturing engineer, you have a target on your back, and they don't like you at all, and they're vocal about it. And so it's a real challenge to like do your job, because they're kind of working against you in a way. They don't want to change things. They see you as the manufacturing engineer as the guy that's trying to eliminate their job. So they're very aggressively passive when dealing with you. Whereas Blunt was non-union, and you still get some resistance. You know, people are somewhat resistant because your entire job is to come in and implement change and try to find better ways to do things. And sometimes people take offense to that, you know, so there's a big challenge there. But it was different in that they were non-union. We all worked for the same company, and it was a lot easier there to develop your ideas, because people weren't as aggressive, you know. Even if they maybe resented your presence, they weren't aggressive about it, right? So it was much easier to deal with there. And Blunt really felt like a family company, whereas Daimler felt very, you know, big and corporate. But Blunt is also very big and corporate, so it was an interesting kind of a change. Yes.
What about the chrome? Is that for hardness?
Yes.
And so if you sharpen it, doesn't it just take off the chrome? Or will it?
Well, that's a good question, actually. So I'm going to say this is from the business end of the cutter link, right? Is shaped somewhat like this. So, and then you have your tie strap link that goes in here. And what happens is the only surface that gets chrome plated is this surface and this surface, because these are your cutting surfaces. And when the operator goes to sharpen it, they actually use a round file and they go in at an angle like this. And so as you're filing, you're only filing this surface and this surface away, and you're creating the outside edge, which is where the chrome is.
Yeah,
So that's where your cutting edge is.
So you always have a
Fresh,
surface that'll
right.
give you the-
You have a fresh chrome cutting edge every time you sharpen your blade.
Assuming you're sharpening it, right?
Right, which is, I'm sure, very, maybe not a safe assumption. But I mean, it's actually, when you see it, if you see it next time you see a chainsaw, look at the link. I mean, it'd be hard to file it completely wrong. I mean, maybe you're a few degrees off on your angle or something, but it'd be difficult to file it totally wrong. You know, I mean, you would, you'd be maybe, I don't know. I think it would be challenging. Any other questions? Well, it was a good internship.
All right. Great. Thank you. Thank you, Council. Thank you.
Bro.
Thanks for coming in.
Did it? I didn't even notice.
Oh, did it? Oh.
Just go to my computer. That'll be something working.
Yay.
Ooh, fancy.
All right, so my name is Kat, and I'm a software engineering intern, and I am interning at CH2M. Who here has heard of CH2M? It's more than I expected. Most people I know have never heard of it.
There's too many vowels, right?
No, they actually have an office downtown in Front. They actually have offices pretty much everywhere, which I will get to eventually.
Right.
So I'm going to go over the company background, my experience interning there, and the insights that I gained. So they were established in 1946 and headquartered near Denver, Colorado. They currently have over 25,000 employees, and they made $6.1 billion in 2014. So it is a huge company. Their operations span 7 continents, and they're recognized. They wrote this slide, so if that's actually true, I don't know. But it says that they're recognized as the most admired company and leading employer. I think they are. So they have offices everywhere: North America, Latin America. I think it's kind of funny that they put Mexico under Latin America, not North America. Europe, Asia, Australia, everywhere. Like, if you want to work for CH, you can live anywhere. Doesn't matter. They say that they're an engineering, design, and consulting firm, and if that sounds vague, it's because they have such a broad amount of work that there's no more specific explanation than that. So unlike his company, which is just chainsaw chains, they do everything. They decommission nuclear build plants. Yes. They do water treatment. They build bridges. They do semiconductor plants. Probably other things I don't even know about. The group that I work for is in the industrial and urban environments and the advanced facilities specifically. So they do things like electronics, such as semiconductors, energy storage, solar, nanotechnology, aviation, I mean, anything. If it's engineering, they do it.
You have a research department?
I'm sure that they do. They do so much that I don't even know about. Some major projects that they worked on, the 2022 World Cup, the 2012 Olympic Games. The interesting thing about this one is this was the first Olympic Games that had been constructed where there was not a fatality. And CH really prides themselves on that because safety is a huge concern of theirs. And so they were able to do it without anybody dying. Which, I mean, it's crazy that that's a thing to brag about.
They have construction management as well, so they were a big part of the actual management of the construction.
Yeah, they do consulting and they manage a lot of that. A lot of these other things I haven't even heard of. You can see they're around the world. So my specific experience, it was 40 hours a week if I wanted to work it. If I had to work less because of school or I was sick or any reason, they were super flexible about it. Most people work 9 to 5-ish, but there were some weeks I worked 7:30 to 3:30 because I didn't want to deal with traffic. I currently work 9 to 5 because where I'm working now, there isn't traffic. I like to sleep in. Sometimes I work from home. Sometimes I work on the weekend. It's just, they were super flexible. As long as I got my work done, they did not care when I came in. $21 an hour, not bad for an internship. They did 401k matching, health insurance. It's not great health insurance, but it's health insurance. No vacation or holiday pay, unfortunately, but they do have some perks. Like they do have a gym there, and it's nice place to work. They don't mind if you take the holidays off. They just won't pay you. You'll be the only one in the office if you go. So, for organizational structure, that was unique for me because they're not a software company. Despite all the engineering they do, software engineering is not one of those. So they have a lot of internal tools that they use that some person who took a programming class once or twice hacked together, and it's never quite worked exactly right. And so they had the great idea of hiring a computer science intern to fix all of those tools for them. So nobody understood what I did. Nobody had any idea how long it should take me to do it. They said, please fix this, let us know when you're done. And my boss, all he did is make sure I had enough to do, which was never an issue because I'd always have at least half a dozen people begging me to fix something. So I wouldn't say I reported to different people, but I would communicate and collaborate with them and get my requirements for what needed to be done from different people depending on the project. A lot of times I had to go seek out input, figure out what does this need to do. I'd have some guy come by my desk say, like, this doesn't work, can you please fix it? And that was all the feedback I had. So I had to go ask around, what doesn't it do? What's wrong with it? And if I would get stuck, because a lot of times they interface with other systems. The first was also made by some person that took a couple computer science classes and hacked it together in like 1993. And so I would try to get my new version to connect to their version and have to try to track down the department or the person that was stuck maintaining that. And so it was interesting. And I had to talk to people from everywhere. Like I regularly had Skype calls with someone in Phoenix and Philadelphia and wherever I could get help, I took it. The 4 main projects that I worked on were an interactive risk analysis, a task list, business development pipeline, and QuickBase, which is an online cloud-based database. And I had to deal with all of these technologies, so Access, Excel, VBA, Visual Studio, multiple browsers that all had to be constrained to a certain version because they're using old software or new software. So whatever you've already learned probably won't help you. You'll have to learn something new no matter where you go. You might as well just get used to it. The first one, this is an Excel customization. Is anyone familiar with what a Monte Carlo analysis is? it's a statistical thing. So if you have a whole bunch of, in this case, it's risks, and they all have a different probability of happening, and they all have a range of costs that they might cost you. So maybe it's $10,000, maybe it's $50,000, and so you're trying to figure out what is the project likely to cost me. It runs a whole bunch of simulations where it pulls different probabilities and then picks a number in that range and adds them all up to kind of give you an idea of how much will this project cost. So in this case, there's like a 1% chance of it only costing $9 million, a 10% chance of it costing about $10 million. And then there's a good chance it could fall up in this range where it costs you like 10, 11, 12 million. So that's good to know, so they can say, I want to give 80% contingency. So 80% of the time, my budget should cover my project risk. This was mostly working when I got it. I fixed some really minor issues, and they were minor things like the text didn't wrap properly, or like little UI things. It mostly worked, and I was able to talk to the person who had worked on it before me, which was really helpful. And he was one class short of a computer science minor, so he mostly knew what he was doing. I could go and ask him a question in like a softer mind, and he'd be able to communicate with me in that way. So it was rare at that place, and I got spoiled on my first project, but it was cool. I had a whole bunch of features, updated it. It was written back in like 2003, and they've added that whole ribbon thing that everyone hates now. And so I moved a lot of the buttons to there and added some features like the archiving would make a new sheet every time you made an archive. And people would have these year-long projects and archive it every week, so it got to be a little annoying. I fixed that. So it wasn't a huge project, but this is what they gave me the very first day I started, and just gave me a bunch of code and said, make it better. The task list, on the other hand, there were so many bugs in this, and they were so hard to find. It'd be like, if you opened it and then you did this one action as your very first action, and you like had this tab at a certain zoom, and you had this other tab at this other zoom, and it's like this very specific case, and it wouldn't always break. It wouldn't always give the same error. And it still has some weird little quirks like that where it'll work fine and then it'll just crash. And you'll have no idea why. But the person who wrote it, he'd been spending probably years on and off trying to fix these bugs that were actually bugs in Excel itself. Or it wasn't his code, it'd be like a memory management error if you try to copy a hidden row in these really specific set of circumstances. And he wasn't able to fix it, but I fixed pretty much everything. And I had a lot of people that were very happy because they would use this program. And when it would crash, it wasn't even like usually when Excel crashes where it will recover it for you. It would be gone. Completely gone. You would have no version of it except your last saved version. And it would crash like every 5-10 minutes. So it got to be super annoying for people. So I fixed it, saved lots of people a lot of time because every program or project manager uses for every project. It's a labor cost estimation tool. So they would put in all their tasks and then assign how many hours that task would take and assign a specific person to do that task so they would know the exact wage and all the indirect costs like your benefits and your unemployment and all that. So they would know exactly how much this project is going to cost them in labor, which allowed them to give a better estimation. And they had to do this for every project. It took a long time and it crashed all the time. And I had people come to my desk like every day for a month thanking me after it was fixed. The other thing I did is I moved it from VBA, which is the code inside of Excel, to VB.NET, which is more robust and you can do it in Visual Studio. Honestly, I felt like there was no real point in doing this because I don't think there's a single person at CH that knows VB.NET. But the person who made it asked me to do it, and thinking back on it, I wish I told him it was a bad idea and it was a waste of my time and it was a waste of their time because nobody cares. They just wanted the bugs fixed. No one even uses that version, and I could have been doing something else. So Don't be afraid to say that. Someone says do something and you say, no one is going to care. Don't pay me to do that. Pay me to do something better. Don't be afraid to say that. They'll be happy. The last one, this wasn't a whole lot of code challenge. It's another Excel customization. You notice the trend here. Engineers love Excel. It's their favorite thing ever. They won't make anything do something in Excel. They'll use Excel for everything. Like if you should use Word, they'll use Excel. PowerPoint, they'll use Excel. Database, they'll use Excel. It doesn't matter. They just want everything in Excel. So that's okay. You're really good at Excel. I am an Excel expert now. This is the tax sales, opportunities, chances that they succeed, who sold it, who isn't selling anything, and they just wanted to automate some of that. This was more challenging because I didn't have any programmer to go to. I was talking to someone whose boss wanted some things done, whose boss's boss wanted some things done. And then by the time it trickled down to me, it would be this really convoluted request. It didn't make any sense. And they'd be like, can you do that in 10 minutes? That'd be great, thanks. Literally, she came over to my desk once and said, can you do all this, like X, Y, and Z in 30 minutes or less? And the person sitting next to me was like, does that happen all crazy? So, and at first I tried to do everything that they asked, and it was really frustrating because I couldn't get it done well. It would be buggy and it would break, and my code was just spaghetti. And so I went to go fix it. I couldn't, and it was never what they actually wanted because that's how it always is, right? And I eventually had to stop and just kind of push back. They're like, okay, I need some research here. We need to sit down and talk about it first. I know you're busy. It doesn't have to be you. I can't do all of this. You need to prioritize what are the top 3 things that you need so I can do them well. Don't be afraid to do that. They'll ask the world from you, and you need to be reasonable. And don't feel like you have to do the impossible. You have to work hard, but you don't have to do the impossible. So I learned there, communicate, don't be afraid to voice your opinion. This last one is what I'm mostly working on now. It's a cloud-based database because the project I'm working on involves several different companies. And so they all need access to the same information, and they can't, for the life of them, do it on their own servers for some reason. So we're using this. It's very annoying. It doesn't do anything that a database should do. If you're familiar with databases, it doesn't do things like cascade deletion. If you delete a parent, it doesn't delete all the children. If you try to copy something, it has this awesome property where you can select fields that you're not supposed to copy when you copy that item. And then they have a custom button for copying that item with its children. The two don't work together. So that's fun. It's really weird. Just the navigation is weird. Everyone hated it. They have to go to 10 different pages, and it would never save where they were, and it would just throw them back on the home page. And so when I got there was a lot of crying about it. Legit, it was totally justified. And I worked on it. I had to use JavaScript for this, which I wasn't crazy about. I hate JavaScript. It's the worst thing ever. But that was the only option, so I had to learn it, and I had to use it. And I eventually, well, and then the other fun thing was that even if you could get, everyone would complain, but they all wanted it to be different. Because you have all these different companies, all these people work at these different companies, and they all have their really set way of doing things. They're like, I want these items categorized in this way. And this other person was like, it should be this way. I've done it for 20 years. It works great. And this other person's done it their way for 20 years. And they'll argue about to the end of the days, but they'll all come directly to me like, oh, you should do it this way. That would be really great. And then at first I would just do it. And then 10 minutes later, someone would come in and be like, it just changed. You started doing it this crazy way. I don't understand. So I had to communicate with the whole team, figure out what was actually the thing that worked the best for everyone, or at least what they could live with, make those changes. At the end, people don't complain about it nearly as much anymore. It's really great. I go into the office and I can go like a whole hour without anyone coming to me complaining. I had someone come to me on Monday, in fact, and say that it takes him 25% of the time that it used to enter stuff into the database now. The other fun thing about this project is just the environment, because I work downtown, which is this big, beautiful building, which is mostly empty because no one works in the office. You have these giant desks that no one ever sits at. You can see sunshine out the windows, and it's a really nice place. Then they moved me to this client site where they just have tables like this, except you probably have about twice as many chairs on each one. And the chairs aren't adjustable. And there's just these post-its all over the walls everywhere
Oh.
because it's lean. You just scribble stuff on paper to stick it to the walls and then rearrange it. And it's probably like 5 sheets deep by now. So
Wow.
it's a really cool project. I can't say anything more than that because it's very confidential. But it's a multi-billion-dollar project for a big company. They're trying to do it in a whole new way that's never been done. All these companies coming together to collaborate. I get to see mechanical engineers, electrical engineers, industrial engineers, project managers, all working together in this really tight space. And I've got to learn a lot about what goes into building one of these really advanced, complex technical facilities. So from a completely non-programming standpoint, it's interesting in that case. Programming on it was not fun though. So, insights gained. Helpful courses, databases. At least know the concepts. You don't have to have SQL memorized, but at least know what a parent is, a child is, relations, that sort of thing. Object-oriented programming is very useful. JavaScript. I took a JavaScript class as an elective, and I didn't pay a whole lot of attention to it. I regret it. Don't do that. Pay attention to your JavaScript class. I spent the first 3 months of my internship trying desperately to avoid anything involving JavaScript. It didn't succeed. It caught up to me eventually. Communication, that was my biggest struggle this whole time. It's just being able to communicate with people, trying not to offend, but also trying to get my point across, trying to get people to talk to each other. And that definitely took at least 75% of my time. Coding didn't take that much time. It was just trying to figure out what do people want, how to do it. I used to have a job tutoring computer science, and that was actually really helpful to me. Probably more helpful than all of these classes combined. It's experience. It helps you. Even if you just do it, like 5 hours a week, it'll help you a lot because it'll make you think about it. Lessons learned. Don't be shy. Speak up. They won't bite you. Well, at least at CH. I don't know about other companies, but everyone at CH is very nice. And just speak up. They'll support you. You just have to say something. Build those relationships so that people are comfortable talking to you. You can understand their communication style. And so when they tell you something weird, you know what they actually mean. When they say the database deleted item itself, they actually meant they clicked the delete button on accident. And you tell them don't do that anymore. Happened this morning. True story. Show confidence in your abilities. At first, people call me and say, hey, we need some help on this database thing. Do you know SQL? And I've been, yeah, I took an SQL class once a while ago. I sort of remember it. And they go, yeah, I think we'll find someone else. Don't do that. Just say, yes, I can do it. Whatever it is, I'll do it. You probably don't know how to do it, but that's okay because you need to be able to problem solve. Exactly. The best thing that my boss ever did for me was tell everyone in the company I was an expert at everything because at that point I had to just go with it. Yeah, I know everything about Excel, even though I've hardly used it 2 weeks ago. I'm an expert. Sure, I'll help you. Yeah, I'll do JavaScript coding, even though I slept through my JavaScript class. Figure it out. Because you won't know it. And it'll always be different. I'm sure you didn't know how to do any of the stuff they asked you to do. Just you won't. Pretend like you do. You go figure it out because I'm sure you can figure it out. We're all smart here. So be confident, be able to problem solve, and don't be afraid to ask for help if you need it. They will just throw you in the deep end, and you have to be somewhat self-sufficient, but don't be afraid to go ask for clarification. Don't just do it the way that you guessed at, because then they'll know that you did it wrong, and that's not going to help you either. Conclusion, sell your skills, be confident, just problem solve. learn to communicate. If you think you're gonna be an engineer in the corner typing away on your computer or drawing on your drawings, that's not gonna happen. You have to be social. You have to talk to people. You have to. You work for Siege, you'll never be bored. They will always have something new and crazy for you to do. Any questions? Yeah.
Did you search through all these companies and then like, just focus on them, try and get them to hire you?
No, so actually, I was a supplemental applicant, which means I did not go through any of the interviews, class, or any training. I got an email from Jay saying that they were short a few applicants. I sent him my resume, and Steve Cook called me and says, I work for CH2M. I want to interview you because I love your resume. And I go, what is CH2M? Why are you calling me? I don't understand what is going on. Did a phone interview and they hired me. So I didn't know anything about the company. I didn't know anything about MECOP except that I heard it was good and that I should join. So,
You think they'll hire you?
oh yeah, they're begging for me to stay.
You have a very high likelihood of getting job opportunities in the program, for sure.
Mhm.
If you know, do your work and make friends. Like she said, definitely don't necessarily just drill down on the work and also work at the social side of it.
Mhm. Yeah, definitely. I've made some friends there. I've gone to after work parties that I didn't really want to go to, but just being friends with people, especially the people that have the authority to hire you, it's very good. But yeah, they haven't ever had computer science interns before or software engineering. They don't have a software engineering department. What they found with me working there is that they really badly, horribly need it. So, and what I've managed to do is start about half a dozen projects again, about halfway done. And my internship is supposed to end in December. So I figure I've got pretty good leverage to stay on. I figure I'll just delete all the comments and get fired.
You have to hire.
But no, yeah, I haven't got an official job offer yet. And I keep asking my supervisor, he's like, please don't panic. Do not leave. Do not go somewhere else. I will get you a job. So.
So
Anything
you
else?
just did the one internship then with me?
Yeah, because I just applied. I'm not even technically eligible because I graduate next quarter. So, and I hadn't done any internships, but because they were missing applicants, they're a lot less lenient on their requirements. Apparently they have more jobs than people. It's hard to believe. Maybe it's a software thing because the demand for software engineers is really high in general. Like even halfway competent engineers can generally get hired somewhere.
Oh, so those are the ones that decide myself before they.
All right, thanks, Kat. All right, thank you. Thank you very much. Well, I see that we